Hi everyone, welcome back to Linux. Today we are going to see about total waviness of a number in a range. They have been given two numbers, that is num1 and num2, and represent the inclusive range. The waviness of a number is defined as total count in its peak and valley. First, let us see what is peak. Peak is strictly greater than both of its immediate neighbors. For example, let's take 141. 141 or 142 is also okay. Here the digit 4 is called peak because it's strictly greater than both immediate neighbors. So it's in a peak. For let's take another example, 144. Here the center digit 4, it's not a peak because it's equal to a name adjacent neighbors, that is 4. So it's not in a peak here. Let's take an example for valley 424. Here the digit 2 is called valley because it's strictly lesser than both of its adjacents. So it's called as valley. Okay. And the first and last digit of a number cannot be peak or valley because if you have two values like 23, each value must be strictly lesser than both left and right numbers, right? So if you take a 2, there is no left number, and for a last number 3, there is no right number, right after the number, right? So it doesn't have any peak and valley. And any numbers which is fewer than 3, that is total waviness is 0. Okay. Return the total sum of waviness of all the numbers in the range num1 and num2. Okay. We need to find all the peaks and valleys in this range of numbers and sum them up and return. And this, let's see in the let's understand this example. For example 1, the range from 120 to 130. Okay. So it's an inclusive, right? So 120. Number of peaks is only one peak, that is 2, one peak, and 0 valleys because, sorry, 0 valley. Okay. 121 also one peak, 0 valley, and 122 also doesn't contains any peak or any valley because whenever we take 2, this is equal to that, so it doesn't contains peak or valley. And after the subsequent numbers, this this single digit will be increasing up to this, up to 129, 129. So up to this there is no peak and no valleys. Once it's reached 130, it contains another peak. So in total, and 130 is in a, that's in a end of point. So in total there is 3 peaks and 0 valley, that is one peak here, one peak here, and two peak here. Sorry, one peak here. Total of 3 peaks, and answer is 3 plus 0 is 3. So this is simple understanding. And if you come to this constraint, the nums of 2 is 10 power 5. I think the brute force work here because, and worst case, the 10 power 5 can be written as 10 0 0 0 0 and 0. What I can do was go to each number and iterate to this digit. Okay, this digit. At worst case, this will be 10,000. Sorry, 1 lakh into 5. that is 50000. This complexity, at worst case, that is 5 lakh complexity, which will be accepted by LeetCode, so it will be work. Let's go for it. um there is a base case, when the number is less than a 2 digit, there is no value. So what I can do was, if nums of 1 greater than, sorry, lesser than 99, I just put nums of 1 equal to 100. Then what if nums of 2? So if nums of 1 is greater than nums of 2, we just return 0, because like if nums of 1 is 1 and nums of 2, sorry, num2 is 66, what we do was, in this step, we turn 1 into 99, which is not in a range, which is lesser than 66. In that case, there is no value, we just return 0. And if it is false, it's just come out this if statement, and we go for an loop. For I in range, num1 to num2 plus 1, because the end is inclusive in range functions Python. And each number, I'm going to iterate each digit. Okay. I take last equal to I modulus of 10, and I double slash equal to 10. I equal to, what I did was here, let's put it command. I will as in a value like, let's take 120, and the last will store as 0, because 120 modulus of 10 is 0, and I will become 12. And let's go for a while loop. While must be greater than 9, because if it's lesser than 9, which means the number is lesser than 99, because we take one value, right? We take one value out of it, so the remaining value should be greater than 2 digit. If it's lesser than 2 digit, then it's overall it has only 2 digit. If it's in a 2 digit, there is no value, right? It's no value waviness, then it should be 0 peak and 0 valley. So I must be greater than 9, so it has a 2 digit. In total there will be 3 digit. So in that case, mid equal to I, again I modulus of 10. Okay, and I double slash equal to 10, again divide by 10, so the last digit goes out. And first equal to I modulus of 10. Okay, if let's go for peak check. If mid is greater than last and mid is greater than first means I increase peak plus equal to 1. Let's define peak here. P equal to 0 and value equal to 0. If mid is lesser than last, this is for an valley, and mid is lesser than first, this means it's in a valley, v plus equal to 1. And that's it. We are dividing I here, so it's basically after a few steps become 2 digit, and we return just p plus v. I think it has worked. It will. Oh, there is an edge case for us. Not working. Let's see why it's not working. Ah, I see. We found out made and we divide I and lost. For a next iteration, this made becoming a lost. Maybe previous word kind of makes sense. So after the each iteration, I just previous equal to made, and wherever I put made, sorry, not this, where I put lost, that is previous. Okay, now it has to work. It will. Let's submit it out. Yeah, it's worked and submitted. And that's it from this video. Let's see you on next video.